Hi there, my name's Joe Spencer, and I'm going to talk to you about my work on optical spectroscopy of extreme nanowires, which is basically just a fancy way of saying I look at really small things. But when I say small, I mean incredibly small. You see, I work at the nanoscale, but what is nano anyway, and why should you care about it? Well, a nanometer is defined as a billionth of a meter. To put that in a bit of perspective, it's about the distance that a Navy frigate sinks if a seagull were to land on it. And we should care because nanotechnology is all around us in our daily lives right now. If you were to look inside your mobile phones, you'll find tiny nanoscale electronic devices called transistors. And in a good smartphone, there are about the same number of these transistors as there are people on the planet. And we scientists, we want to make these things smaller and smaller so we can pack more in and make our devices perform better and more efficiently. So what exactly do I do in this huge but tiny industry? Well, as I said, I work on what we call extreme nanowires. I make wires that are just 1 or 2 atoms across. It's literally impossible to make them any smaller. And are they difficult to make? Well, you tell me. I start with a material that I want to turn into a nanowire, and then I get these things called carbon nanotubes, which are kind of like nanoscale straws made of carbon atoms, and I grind them up in a pestle and mortar, and I just put it in the oven about 800 degrees or gas mark 70. And the material melts down, and these nanotubes, these straws, they literally suck up all the melt, forming my new nanowire. So great, I've made these things, right? Let's put them in devices and have the best technology possible. Well, there's more to it than that. You see, it turns out when you make a wire just a few atoms across, the physics of materials at this scale is very different from what we'd expect. The atoms sort of bond in different ways, forming new versions of the same material we've never seen before, with entirely different properties. Kind of like how diamond and coal are made of the same stuff, but they behave very differently. And it's these differences I'm interested in looking at using optical spectroscopy. Specifically, I use a technique known as Raman spectroscopy, where I look at vibrations in a material to learn information. What exactly do I mean by Raman and vibrations then? Well, imagine it like this. Imagine you're knocking on the side of a wall, listening to the sound or the vibrations that are produced. And then all of a sudden the sound changes, probably because there's like a cavity behind there or something. You've learned information about your sample, your wall, based entirely on the differences between the vibrations you've picked up. And that's essentially what Raman is. Except instead of hitting a sample, I shoot it with a laser in my lab because that seems more fun. And I look at the Raman spectra. And you can see in this graph behind me, this blue trace corresponds to the vibrations or properties of the material I started with. And this black trace corresponds to the vibrations or the properties of the material, my new nanowire that I've made. And you can see that they're very different. And it's important, really important as physicists, that we understand these differences and what causes them and what it means for the properties of materials, especially as our technology is very fast approaching this fundamental limit of miniaturization. So keep your eye out for nanotechnology, because it really is the next big thing. Thank you.
Thank you.